welcome to my second video in the fourth chapter for our Unity project. We're going to take a look at getting enemies to stay dead in between scene transitions and adding an option to make it so that you could choose whether or not enemies actually kind of follow that restriction. Which would be useful for like boss encounters so that you can't like respawn the boss. And an extra video, we will take a look at implementing respawn timers. However, respawn timers are a little bit tricky to the point where they would deserve their own video after we get this functional. And so to begin that, let's pick up and we're going to want to take a look at the enemy script. But first, I do want to take a quick detour into the game controller script. Oh, I guess I don't want the game controller script. I wanted the data dictionary script. So this is our dictionary that we're working on. And as I was planning out the respawn timer, I do want to tweak our initialize check method a little bit to make it a bit more user-friendly for future editions. And that just means modifying this last part. And instead of returning false after creating the dictionary, we're just going to wait till we're all done to return true. Since that whole returning wasn't super important, this will make it a little bit more easier for us to add different types of data inside of this in the future, which will facilitate respawning. That video is going to be long enough as it is. Alright, so we've got that. We made that quick little change. And then if we go over to enemy, well, enemy is going to need to add its own way to track this data dictionary. So I kind of feel like that is mostly a health related thing here. But the data dictionary probably should be stored up kind of towards this generic part. So I'm going to put it right under enemy name. Tooltip. So public, this was a data dictionary, and we'll just call it data. And so that will be the name of the internal reference to accessing this. And then under health, we would want to have an option for does this creature stay dead. So maybe right under max health, we're going to add a public boolean for, no, just call it stays dead. We'll initialize it to false. Does this creature so if stay dead is false, well, let's see. I'll just call it allow respawn. And we'll set that to true. So the default behavior is monsters will come back when you reload the map. And we want to start handling a lot of this during the start method, which has been kind of buried down here about like line 90 or so. But in addition to that, we are going to need a few useful other methods. And I think I'm going to just tack that into this update behaviors region, even though I've got a lot already here. And this is going to be the method we're going to use to generate a unique name for this monster. And that's because when we were looking at this dictionary, I had said that it's going to be able to attach a string to a true or false value, and that's going to remember if the monster is dead or not. But in reality, Orange Blob 1 isn't a truly unique name, because if we go into another scene, there might be another orange blob 1. You can even just see from my hierarchy here how things end up getting named. There's orange blob 3 or whatever. But what could be actually a solution to that problem is if we attach the name of the scene in front of it, because we know that every object has to have a unique name in the scene, and obviously each scene is going to have a unique name. So if we construct a name for an enemy that puts the name of the scene and then the scene's name for that monster, this key will be unique in the dictionary. So no matter what level I am on, overworld orange blob 1 only refers to one individual enemy, whereas orange blob 1 could refer to several different orange blobs, each of them on a different map, because you might be on overworld south, overworld east, cave 1, but this will guarantee that that name is truly unique across everything inside this dictionary. And so that's going to be the purpose of this get unique name method. So I'm going to add it inside of here. It's going to be a protected type, protected string, get unique name. And I think we're going to need access to scene management here to get the name of the scene. So up here at the top, we need to add using Unity engine dot scene management. And then we're going to head back down to this get unique name method, and what we're going to do is just return scene manager dot get active scene dot name plus a colon plus game object dot name. And so you can see that just from how this is going to behave, we're going to have a bunch of unique names, and this is going to be perfect for use with that dictionary. So that's our get unique names method. And I'm going to minimize that. And now that we've hopefully got that, minimize that. And inside of update, I'm sorry, not update, start, that's where we're going to have to start adding the logic to see if this creature is going to come back. So towards the end of start is where I'm going to do this. So it wants to check to see if the creature should or should not respawn. So first off, we need to make sure that this data dictionary exists. And we had that method called initialize check, and that makes sure that exists. So upon doing this, we are guaranteed everywhere inside this enemy script that it is guaranteed to exist anywhere else. So we only need to do it once during start. So once we've done that, we just need a Boolean called found, because the way that this works is it's kind of weird. Let's do data list. Oh, it's called data. Data dot data Boolean. And now normally you could just reference it like this. And actually, like this is how you should be kind of thinking about it. That would evaluate to true or false. Well, it needs to be put somewhere in a useful context. But if this name doesn't exist, it actually throws an exception, which means we crash, which we don't want. So there is a built-in method called try get value, and then if we put in, you know, the string that we want, and then we use the pass by reference feature here, it will pass it back out to this Boolean and return true or false into there if it finds it. So if this name doesn't exist, found will be false. If this name does exist and the value is false, then this will still pass in to be false. So, oh, well, yeah. All right, so let's give this a shot. Oh, but instead of monster name, we want to use get unique name. Uh-oh. Did I misspell it? I think I did misspell it. So it's going to pass in that unique name and see what happens when this tries to get the value. So if allow respawn is true and it was found and play. So this will return true if it finds that to have set to true. Otherwise, it will return false if the value is false, and then if it wasn't found, found would be false. Is how that would work. And then so we'll just call destroy. So if it, oh, we gotta update this a little bit. Yes. So if we have allow respawn unchecked, that means the monster should not be coming back. And then if we find its name in the list, then it should pass it. All these checks will be true, and it will then destroy the monster. So all we've got to really do now is inside of my death script, inside of check health specifically, if the monster is supposed to not come back, we just need to add that to this dictionary. Should be pretty easy to do. So I'll just do it right in front of this health is less than or equal to 0. If health is less than or equal to 0 and allow respawn is false, data boolean get unique name equals true. And so it's going to mark that monster is dead. Notice how you can treat it very much just like a regular array is basically what I'm doing here. Just using a string to index inside of an array. And this actually inserts the element automatically and inserts it set to true. So we can save that. And we will have to update one other little piece. Because that other piece is going to my brain has stopped. Inside a skeleton, skeleton does override this check health script, so we are going to have to take this piece and copy it and go place it inside of check health of the skeleton. So like if we go looking through right here, we can see that skeleton overrides this, and we just need to do the same thing here so that when the skeleton should be dead, it's going to do the same thing because it completely overrides the existing check health. Alright, with those changes, we should actually be able to see this in action. So it's going to compile. We're going to have to update the prefabs because they're going to need to have a link to this scriptable object here. So if we go look at the prefab, you can see that there's a data a data dictionary right here that it wants, and we have to go link data to it. And we need to go do that for the blob as well. Now these creatures are set to allow respawn true, so let's see what happens. They should be respawning when we defeat them. So if I go and kill these two slimes on the bridge, they should come back. Now if I go and set those slimes, if I change these and uncheck allow respawn, wherever that happens to be, then these slimes will not come back. Oops. I forgot that we have to start it on the main overworld because that's where the start location is configured to pick up from. So now when I defeat these slimes, they should not be coming back. And you can see that the one that I left alive, now he is back to full health. We didn't track his health, but now those slimes don't come back ever. So all you would have to do is just check or uncheck that box. And if you have it unchecked, it will not respawn. But right now, if it is checked to allow respawn, that's what it's indicating, is that that monster will be able to come back. And like I said, in a different video, we'll use this to add like a respawn timer, so monsters can come back after like 2 minutes or however long. But that is actually complicated enough that it will deserve its own video. But for now, that's all we really need to do to allow enemies the option to not come back when you defeat them. So we have this inside of start. I should probably add a few comments. So let's call this so we have a little bit more clarity in my variable names, because it actually does put the result of this of the key linkage into this isDead variable, whereas this just returns true or false based on whether it found it. So this piece here returns true if it even finds the key, and then this is the result of what it found. Cool. So we'll save that, and we will kind of call it quits here. And so that just deletes it immediately on the level load. Like I said, so on here, in a future extra video, we'll look at respawn timers because it is kind of complex to set up. And in the next video series, we're going to look at actually creating switches that actually operate on a very similar principle as this monster respawning, and be able to hit a switch and have it remember the state of the switch and have it open doors, open pathways, etc., etc. So see you for that video.